Alright, so we're going to look about sampling variability and sample size. So sampling variability, that just means each time you take a sample, you're going to get a little bit of a different number, right? So if I take a random sample of, let's see, math, probability, let's just say I take a random sample of people from 1 to 5. There's 5 people and I want to take a random sample. I have 4 people, or 3 people. So I take a sample of 3 people. There's my first sample. So I had 4, 3, and 4. And then I take another random sample. My next random sample was 4, 1, and 3. And so it's a little bit different on each sample. And so that's all just saying. So it's okay that when I take samples repeatedly, each sample might be a little bit different. And that's okay. Alright. The other thing that we're going to talk about here is the average result. So if we do a good job, if we take something that's non-biased, it is a random sample, it's all good. If we do that repeatedly, that means that our results are going to be correct on average. So right, they're going to be different, a little bit different each time, but on average, if we did a good job, they should all be fine. Okay? And if we repeatedly, it doesn't matter if it's a small sample or if it's a large sample, it's going to be equally good on average if we took a random sample and it was not biased. Okay, now let's look at this part. So this one makes a little bit of common sense to me. It makes sense to me. So it says, if the results were repeatedly taken from a large random sample, so we have something large random samples will have closer together values. Closer together. They'll be closer together in general, and so they would be less variable. I'm going to show you an example of this in a second. Okay? And so the larger our samples are, the closer it's going to tend to be. Will tend to be close to our true value. Okay, and then we have, what if we have small samples? So small samples is okay. Small samples, though, a lot of times our results are going to be more spread out. Okay, and it's going to be more variable. You're going to have more variability in small samples because you took less people, you have less data, okay? And these are going to make you farther away from the true value that you're trying to look for, okay? And so from this information, we can see here that the larger that our sample is, the better. So the larger our sample is, the closer that we're going to end up to our true value. Okay? So let's look at this. I just want to show you. So this is some data, some stuff that this is just such random data, but it is true nonetheless. So here's some random data. So suppose 45% of Huntingtown High School students like lima beans. I like lima bean soup. It's pretty good. Okay. It says stat students took 25 random samples of 100 people. Okay. So stat students made the big samples. Okay. Stat students. Whereas calc students took 25 random samples of only 50 people. So these are the calc people took small samples. And so I want you guys to look here at some of the data that was collected. Ready? Here is, so this is just saying they took a random sample of 50 people, and each of the X's that I'm going to put is going to represent one sample. So there's going to be 25 X's on each side. So ready? Here's one sample. They took one sample and 20 out of 50 people liked, lima beans. Okay, and so here are the 20 other X's or 19 other X's that we got. So just take a moment. There's 3. For 35, we have 2. For 40, there's 3. For 45, there's 4. For 50, there's 3. For 55, there's also 3. I'm kind of hungry right now. And that. So that is the distribution for small. So there should be 25 X's here. And the 25 X's show the like the random samples that they took that each had 50 people in it. So of the 50 people, 20 like this. Of the 50 people, 40 like this. And this is the spread outness of it. Whereas over here, my stats people went and took 100 people in their samples. And when they had 100 people in their sample, they had 2 samples where 35 people liked it. They had 1, 2, 3, 4, 5, 6 samples of their 25 that had 40. They had 9 samples of people, 45 people that liked, lima beans. And they had 4 that had 50, 3 that had 55, and 1 that had 60. So I want you to look at the spread outness of this. So these samples each had 100 people, and you see that this seems to be congregating around 45. So I would think truly at Huntingtown High School, 45% of those people, like that was the fact, like suppose 45% of them have it. So that's just saying, okay, this was like the given right here. This is like given. This is made up data. Suppose that 45% do like lima beans. Well, you kind of see how right here they're all kind of starting to congregate around the golden number, 45, and you can see that right here. Whereas over here, it's kind of a little bit more blobbed out. So smaller samples don't always give us the best idea. They're more variable and more spread out. So the bigger the sample, the closer it is on average to what we want, what the true value is. And the true value here in this made-up example is 45% of people liked lima beans, and that seems to be true. Okay, in this case. Okay, and so I guess I've been saying in all of these samples like 20 people liked it. I guess that would be 20% of people liked lima beans in those samples.